Excellent progress so far. Now we're moving into more advanced and practical C-Loan topics: formatting output, culture-specific currency, value returning methods, argument passing with ref and out, string manipulation, and an introduction to .NET namespaces. These topics are essential for creating professional, internationalized, and maintainable software applications. Let's jump into it. C# provides powerful format specifiers to control how output looks. Here are a few examples. N2 formats a number with 2 decimal places like 1650. C formats a number as currency, automatically adding the symbol. P formats a value as a percentage. X converts an integer to hexadecimal. E expresses numbers in scientific notation. And for dates, T displays time, and D shows the date. Formatting isn't just cosmetic. It makes your program professional and user-friendly. When formatting currency, regional settings matter. The culture info class allows you to specify different locales. For example, NUS shows dollars, 312.68. NGB shows pounds, 312.68. FRFR shows euros with French formatting. You can format currency for any country just by changing the culture info passed to the toString method. Here are some culture-specific outputs: US English, $312.68, British English, pound 312.68, French, 312.68 euro, Japanese yen, yen 313, Indian rupees, Rs 312.68. Correct currency formatting is vital for global applications. Some important notes on formatting. The 0 placeholder represents the first argument in WriteLine. Locale affects not just currency but dates and times too. E and P are great for scientific and statistical outputs. X formatting is often used in color codes, memory addresses, and technical fields. Formatting helps your program communicate data effectively and clearly. Now let's revisit value returning methods. These methods return a non-void type like int, double, or string. They must use a return statement to send a value back. These methods are extremely useful because you can fit them into expressions, assignments, or even output statements. Here's a full example. The method getLength asks the user for a length in feet and inches. It reads both values, parses them into integers, then calculates the total length in feet, including the fractional inches part. Finally, it returns that total as a double. This type of method models real-world processes cleanly and professionally. Now, let's talk about argument passing by reference. Normally, method parameters are passed by value, meaning a copy is made. But with the ref keyword, you pass the actual reference. Changes made inside the method affect the original variable. In this example, after calling modify value ref number, the value of number is changed to 10, both inside and outside the method. When you pass reference types like arrays, even without ref, the reference itself is passed. That's why, if you modify an array element inside a method, the change is visible outside too. In this example, numbers becomes 10 after the modify array numbers call. Understanding this behavior is key to avoiding unexpected side effects. Use ref when the variable must be initialized before being passed, and the method will modify its value. For example, doubling a number inside a method by using ref. It's especially useful when updating existing data without needing a new return. The out keyword is similar to ref, but with a different intention. With out, the variable doesn't need to be initialized before being passed. However, inside the method, you must assign a value before exiting. It's perfect when you want a method to generate and return a value back to the caller. Use out when a method needs to return multiple values. The caller does not have to initialize the variable beforehand. In this example, getValues out x, out y assigns 10 and 20 to the variables. Out is a fantastic way to efficiently return more than one value from a method. Here's a quick comparison. With ref, the variable must be initialized before the method call. With out, it must be assigned inside the method. With ref, you can read and modify. With out, you must assign a new value. Choose based on your logic needs, existing value update or fresh assignment. Summarizing best practices. Use ref if the caller already has a value and it should be modified. Use out if the method must supply a completely new value. For example, methods like int.tryParse use out to safely return parsed values. Understanding these two mechanisms is critical for writing clean, bug-free C# code. Moving on to string manipulation. String concatenation uses the plus operator to combine strings together. For example, combining first and last names into a full name, John plus Doe becomes John Doe. Concatenation is simple but incredibly powerful for dynamic content generation. C# automatically handles different types when concatenating. For example, a boolean becomes true or false when concatenated. ToString is called automatically to turn non-strings into string format. This allows easy combination of numbers, booleans, dates, and more into human-readable sentences. Even objects like datetime can be concatenated naturally. In this example, adding datetime.now to a string produces the current date and time formatted appropriately. Again, ToString is automatically applied under the hood. C# makes working with mixed data and strings intuitive and powerful. When you have very large strings, it's good practice to break them into smaller parts. Then you recombine them either with plus or through string interpolation. This keeps your code readable, easier to maintain, and prevents cluttered long lines. Now let's shift to another key concept, namespaces. Namespaces organize related classes, interfaces, and types together. They prevent naming conflicts and make code more maintainable and readable. Using directives like using system makes code cleaner and more efficient. Here are some important namespaces you'll encounter. System Windows Forms for building Windows GUI apps. System Windows Controls, System Windows Input, and System Windows Media for WPF applications. System Link and System Data for querying and managing data. Understanding namespaces is crucial for using .NET libraries effectively. And even more namespaces. System I/O for file and stream operations, System Web for web applications, System XML for handling XML data, System Collections and System Collections generic for data structures, System Text for working with strings and text processing. The .NET framework is vast. Namespaces help you find the right tools quickly and efficiently.